Okay, everyone. So in this section, we're going to talk about rates of change in the natural sciences. Um, Basically, it's a little bit of a catch-all. I'm not going to go too crazy into it in this book. We'll talk a little bit more about it when we do Calc 2. But in Calc 1, we're going to talk about motion of a particle that is confined to move in one direction, either forward or backward. It could also be up or down as well. And this is called rectilinear motion. Okay, so basically it's just up or down or left or right motion. Um, so a few facts about this type of motion. Okay, so these are some things you want to just know. Many of you may already know them if you've taken any physics courses of any kind. If v of t is greater than 0, meaning the velocity function is greater than 0, the object is moving up or to the right. If v of t is less than 0, meaning it's negative, the object is moving down or to the left. If the sign of the velocity matches the sign of the acceleration, then the object is speeding up. And if the sign of the velocity is opposite the sign of the acceleration, the object is slowing down. So, okay, so let's look at this first. Let me kind of make this perfect size for the screen. Okay. Oops. So this first example we'll look at is the position of a particle is given by s of t. By the way, this is normally how in this class we're going to write position functions. I think in algebra they call it normally like h of t, but when we're doing position functions, we're going to call it s of t. I've also seen x of t as well. So it says t cubed minus 12t squared plus 36t minus 20 is the position function for this particle. And we will only consider the time interval from 0 to 9. So we only want to worry about from 0 to 9. I'm assuming seconds. The example I chose, I actually don't remember what it was in, but I'm assuming it's in seconds. So it says, what is the velocity function and when is the particle moving right and to the left? So the thing you have to think about is how do you find the velocity function? What does the velocity function stand for? So you guys should know by now that we've talked a lot about what the derivative stands for. And the derivative stands for the slope of the tangent line. It stands for the instantaneous rate of change. And in this class in general, when we're talking about velocity, we're talking about instantaneous velocity. So we need the derivative for this problem. So what we're gonna do is we're gonna say v of t, oops, sorry about that. We're gonna say v of t is equal to 3t squared minus 24t plus 36. Now again, I just called it v of t. I did not call it s prime of t because when we're talking about velocity, I want you guys to be comfortable talking about v of t and s prime of t is the same thing. But in reality, yes, v of t is s prime of t. And then it says, what is the velocity function and when is the particle moving right and to the left? By the way, if we wanted, we could find the acceleration function, a of t, and that would just be what, 6t minus 24, okay? If asked. We weren't asked in this problem, but maybe you will be in another one. That's the second derivative, okay? So it says, what is the velocity function? Okay, done. So this is the velocity function. Then it says, when is it moving right and left? When is it moving to the particle moving to the right and to the left? Okay, so in order to figure that out, we need to decide when the velocity function is positive and when the velocity function is negative. So in pre-calc, if you taken, well, you probably have taken pre-calc. Hopefully your teacher taught you to use a sign chart. So what I'm going to do is I'm going to factor this and set it equal to 0. So I'm going to say 3 times t squared minus 8t plus 12 is equal to 0. Okay, so I set it equal to 0 because at some point the velocity might be negative or positive, and I can figure out when that happens by setting the velocity equal to 0. Okay, and using the sign chart to check the change in signs. So this is going to become 3 times t, what do we got? Minus 6 and t minus 2. So then that means t equals 6 and t equals 2 are our numbers we're going to use for our sign chart. So I'm going to draw my little sign chart here. And I'm going to use 2 and I'm going to use 6. Okay. And then I'm going to test, I don't know. Let's test, say, v of 1. Let's do v of 3. And let's do v of 7. Okay. So when we do 1, we plug 1 into this function. If we plug it in here, we get a negative, and a negative is a positive. So a negative times a negative is a positive. Okay, when I plug 3 into here and 3 into here, I get negative and a positive is a negative. Okay, and then when I plug 7 into there, I get a positive, and that is a positive. And again, once again, remember, for sign charts, I don't care about the actual value. What I care about is the sign. Is it a positive or negative? So I don't really care about the numbers I get, fractions, decimals, whatever, as long as I know if it's positive or negative. So this now tells me, so the particle is moving right. And then what's the interval? Let's see. So from 0 to 2, it's positive. Union 6 to infinity. Oh, not infinity, sorry, wrong problem. 6 to 9, right? Okay. And moving to the right or to the left when it was negative. So the velocity function was negative from 2 to 6. Now, I will tell you, I have seen in some books, they go back in and they plug the actual endpoints in, and they'll plug, you know how our interval is from 0 to 9? So they will actually plug 0 into the velocity function. And if I plug 0 into the velocity function, I get a positive 36. So I have also seen an alternative. I don't like to do it this way, but I do understand the point, where they would say from 0 to 2, union, oops, the 2 is still in parentheses, union 6. And then when we plug 9 in, we get, let me do my calculator real quick. 3 times 81 minus 24 times 9 plus 36. And I get positive 63. So I have seen this. Oops, this is still correct. And then 9, they put a bracket on 9, because in both of those instances, the velocity is still positive. Now, my only problem with this is if you're at 0 time, I guess you could say you have an initial velocity. I'm not a physics instructor, but I think that's why the argument is that you would include it, because it's technically positive at 0. But for me, I in general do it this way. This is the answer I'm going to be looking for. Let me know if you see that in your homework or something and there's some confusion on bracket or parenthesis. I believe this book might use bracket, and then the other book that I normally teach from doesn't do that. It counts as a parenthesis. And again, I see an argument for both. Okay, so we've figured out when it's going left and when it's going right, and then it says, what is the displacement of the particle on the interval from 0 to 9? Okay, well, displacement, now remember, displacement is just how far you are basically from the starting point. Okay, so we started at time 0, we ended at time 9. So if I drove to the grocery store and back, my displacement would be 0, because I traveled the same there and back. I'm right back to where I started. Okay, so displacement is not distance per se. It's talking basically about how far you are away from your initial position, I guess would be a good way to explain it. So what I'm going to do is I'm just going to say S of, now again, we're talking position now. So we're going back to the position function. S of 9 minus S of 0 equals, now when you plug that in your calculator, you should get 81. So you plug 9 in, you plug 0 into the original position function, way back up here, and you should get 81 after it's all said and done. So the displacement is 0. Oops. So the displacement is 0. I'm sorry, not 0. The displacement is 81. Okay. So let's see here. What is the total distance traveled by the particle? Now, this is a little bit harder, because according to this, we've traveled 81, but that doesn't mean that's how far we've actually traveled. So I'm just going to give you guys a little rough sketch here. Let me just do let's do it left to right graph. So it's kind of more like a, geez, I can't draw a straight line. Oh my gosh. I'm sorry, guys, this is really brutal. Okay, that's about as good as it's gonna get. Okay, so let me draw this. Okay, so I'm gonna put some values here, negative 20. Let's go with 0. Let's go with 20. Let's go with 40. And let's go with 60. Okay, so what we need to do is we need to figure out how far did the graph go in the right direction? And then how far did it go in the left direction? Because remember, we figured this stuff out right here. We figured out that from 0 to 2, it's moving right, and from 6 to 9. So if we figured out how far it traveled from 0 to 2, and then figured out how far it traveled from 6 to 9, and then figured out how far it traveled from 2 to 6 on those time intervals, we could add all those distances up and have the total distance traveled. So what we're going to do is I'm going to draw this is from a computer program. I actually couldn't do this on my calculator. I got this from a colleague. So we need to find, I'm just going to show you right here at about -20. It's going to go a little bit past halfway. Oops. And again, this is supposed to be, so it's going this way. And then right there, it's going to turn. Then it's going to come back here. And then it's going to turn again. Oops. And then it's going to go, come on. Okay, I'm over it. And then it's going to go that way. Okay, but we actually know okay, so this is the value when you plug 9 in. When you do S of 9, you should get 60. Let's just verify that. So let's do 9 cubed minus 12 times 9 squared. Oops. 9 cubed minus 12 times 9 squared plus 36 times 9 minus 20. So you get 61. So right just a little bit past that. So that's 61. So that's at t equals 9 seconds. So, come on. So then we have also when we plug 2 in, let's see, when we do S of 2, well, you know what I'm going to do? Let's do this instead. Let's do this. I'm going to come over here and I'm going to do S of 2. So distance equals S of 2 minus S of 0, right? And I'm going to put absolute values around that so that I know I only take the positive, because all we're concerned with right now is distance. Then I have to add S of, when was our other intersection or our turning point? 6. So it turns back the other direction at 6. So S of 6 minus S of 2 plus S of 9 minus S of 6, okay? So what we need to do is right here, this is the first turn at t equals 2 seconds, okay? This is the second turn at t equals 6 seconds, okay? So it went right for a little bit, then it turned back left, so it's going, it's going right for a little bit for 2 seconds or 2 time, and then it comes back, and then it goes back this way, okay? And then we're calculating our distance from here to here, from here to here, and then from here back to here. So we're calculating all those distances and we're putting absolute values because we don't care if it's going left, that still counts as a distance, okay? So if you guys plug all this into your calculator, I'm assuming you can figure that out. So maybe you want to pause the video and see if you get it right, but you should get 145. When all is said and done, you should get 145 when you plug all these in. It's just a calculator question at this point. I just thought you guys might want to see this graph just to see how you can determine by left to right where it when it turns, basically, okay? So another application of derivatives is exponential growth. And again, this section is just kind of a catch-all. I don't go crazy in depth to it, so this will be a little bit shorter video than normal. And it says the rate of change of the population dy dt is proportional to the population itself. So we end up with this dy dt is equal to k times y, the constant times y. Where the solution to this differential equation is y equals y of 0 e to the kt. So this should look familiar. This is basically the PERT formula. Many of you know PERT. This is area or actual value of your investment or borrow on the loan is worth PE to the RT. right? So this is a very similar formula. And in differential equations, we kind of go through where this comes from. But in this class, you're just going to trust me on this, that that's where the formula came from, is from the solution to a differential equation, which we'll talk about in calculus 2, okay? Where y of 0 is your initial population. You have exponential growth if k is greater than 0, and exponential decay if k is less than 0. Okay, so let's just, and again, this isn't really a calculus problem because the calculus is already done, right? They're giving us a differential equation, but this formula that we're using comes from the derivative, okay? Or the using derivatives and the solution to a differential equation. Okay, so here's an example. It says, suppose a culture of bacteria is modeled by exponential growth. After 5 hours, there are 40,000 bacteria. How many were there initially? So what we're gonna do is we're gonna write our initial problem. Y of t is equal to y of 0 e to the k t. Now, I'm going to ask you if you want, and again, this is just a preference. If you want, you could even write it like this, e to the k, and then all of this to the t, okay? This means the same thing. So what I'm going to do is I'm going to figure out, let's see, did I forget to write it? I sure did. So I forgot to, there's an extra sentence here. Dang it. Okay, so I'm going to have to rewrite this, okay? Sorry about that, you guys. I was missing a piece of information. I thought it looked a little like. So it's modeled by exponential growth. Then it says after 4 hours, there are 10,000 bacteria. Okay, and then after 5 hours, there are 40,000. Okay, how many were there initially? Okay, and I see a typo in my notes actually. I think my notes are after 3 hours, there are 10,000. Yeah, let's do this. Let's change this to 3 because otherwise if I try to do it for 4 and I'll think I got the wrong answer. So after 3 hours, there are 10,000. So what I'm going to do is I'm going to set up something that I know. So I know one of the pieces of information they gave me is that there are 10,000. And we know that this is y naught, or y of 0 e to the 3k. And we also know 40,000 equals y naught e to the 5k. All right. So what we can do, let's divide both equations. Okay. So we're going to take and we're going to do 40,000 divided by 10,000. And we're going to take y naught e to the 5k, and we're going to divide that by y naught e to the 3k. Okay. So when all is said and done, this cancels with this, and we're left with 4 equals, this cancels with this, e to the 2k. However, remember I told you that you could rewrite it like this. So this really means 4 equals e squared k, right? So, oops, e to the, I'm sorry, I did it backwards. E to the k t, okay? So, this number out here is actually 2. You know what, that's getting too fancy. I don't even want to mess with it. Let's just take the natural log of both sides. ln of 4 is equal to the natural log of e to the 2k. Let's see here. Let's move it to the front. ln of 4 equals 2k ln of e. We know that cancels and becomes 1. The natural log of 4 is equal or over 2. So we have k equals ln of 4 over 2. And whatever decimal that turns out to be, that's what our k is, okay? Let's see here. I think that's good on that one. And again, this one is kind of brief because there's not a lot of calculus to it. The calculus will be next semester when we do the logistic model and where it came from. And then we build the exponential growth model also. Okay. So one last example, and then that'll pretty much be it for this section. I don't like to cover every single topic that's in there. So let's see. It says a rock is tossed off the top of a building that is 100 feet tall. Its position as a function of time is given by S of t equals 100 plus 192t minus 16t squared. Okay. So the first thing I want to find is find the velocity and acceleration of the rock as a function of time. Okay, so let's do that. So we know that V of t is equal to 192 minus 32t. And we know a of t is the second derivative, the acceleration function is the second derivative, and that would just be negative 32. Now, coincidentally, I believe this is the acceleration of gravity on an object in free fall in terms of feet per second squared. In meters per second squared, it's negative 9.8 meters per second squared. So this is just the conversion, I believe. But, you know, it's no big deal. Okay, so let's see here. So we have that. Then it says part 2, when does the rock hit the ground? Okay, and then what is the velocity? Okay, so when the rock hits the ground, they want to know how fast it was going. So this isn't a trick question. It's not like they want you to say, oh, it's going 0 because it hit the ground. Remember, we're doing instantaneous velocity, so we can actually find out how fast it was going that moment in time when the limit, you know, the distance between them was infinitely close. We can find out that split moment in time, okay? Where they're so close to each other that you can no longer tell the difference. That's the velocity we're looking for, okay? So when does the rock hit the ground? Well, the way we're going to figure out when the rock hits the ground is, don't we have to set the position function equal to 0? Because that'll tell us when it's on the ground. So I'm going to take S of t and I'm going to set it equal to, or I'm sorry, let me write this out. S of t equals 100 plus 192t minus 16t squared. And we're going to set that equal to 100, okay? I'm sorry, what's wrong with me? I'm getting tired. Set that equal to 0, okay? So we're going to have to factor. I don't even know if this is factorable. You know what? I'm just going to jump right into Pythagorean theorem. So I'm going to say t equals negative b. So this would be negative 192 plus or minus the square root of b squared, which is 192 squared minus 4 times a, which is negative 16, times c, which is 100, all divided by 2 times a, which is negative 16. So let's see what we get on our calculator. 192 squared, and a minus becomes a plus. So that's plus 4 times 16 is 6,400, or 64 times 100, plus 6,400. I'm going to do the square root of that. I get 208. So this becomes t equals negative 192 plus or minus 208, all divided by negative 32. So then t either equals negative 192 plus 208 divided by negative 32, which would be negative 0.5, or t equals negative 192 minus 208 divided by negative 32. And I get positive 12.5. So we don't really have negative time. We don't talk about before the event occurred. So we're going to go with t equals 12.5. So that's how long, that's when it hit the ground, when it hit. Okay, so we got our 205. Now they want to know how fast was it going. So now what am I going to use to figure that out? So hopefully you guys are thinking in your mind right now that, well, I know the velocity function will tell me how fast something's going. So I'm going to do v of 12.5 equals, and then we just look at our velocity function, 192 minus 32 times t. And I believe you get negative 208 once you plug that in. Yes, you get negative 208. So we now found our velocity, all right? So this is our velocity function, how fast it was traveling when the rock hit the ground. Now they didn't, let's see here. Did they give us measurements? They said feet, and I'm assuming seconds, so we're going to say negative 208 feet per second, okay? So that's that part. Now there's one last question. Oops. So the last question says, when is the highest point the rock reaches above the ground? When is the highest point the rock reaches above the ground? Okay, so now we got to think. Okay, now you could do this with pre-calc. This is a college, or this is an algebra problem. This is basically, notice the function. What shape is this function? This function is a parabola. So we could just find the vertex of the parabola, and that would be the highest point, right? But I want to try to practice using my calculus just to kind of show you that it can work on problems that you have that are simpler. And then you could also use this for a more complicated problem, okay? So that means I need to find when it changed direction, when it went from up to down. So what I'm going to do is I'm going to take my velocity function, v of t, and I'm going to set it equal to 0. Because when the velocity is 0, it's that moment in time when it's no longer rising or going downward. It's just kind of free fall or free floating right there, just for a split moment, okay? Not even a second, right? It's just a moment, okay? So then we have, we know our velocity function is negative 32t plus 192 equals 0. So then we solve, so we get we get 192 equals 32t, divide by 32, divide by 32, what is that, 6? So t equals 6. So once again, we take our sign chart and we go t equals 6. Now, the thing is I only care about when it's positive and when it's minus. I want to make sure that it changes direction. Even though I already know the answer at this point, I know the answer is t equals 6, but I'm just going to check it with my sign chart. So when I plug in 6 from the left-hand side of, I guess I should have factored this, negative 32, and this would be t minus 6 equals 0. So now I can plug in v of 5, and I can plug in v of 7. Right? So when I plug in 5, I get a negative, and a negative is a positive. So this is it rising, it's going upward. Okay, its velocity is increasing. And then it's slowly decreasing. And then right at 6, it's going to change from positive velocity to negative velocity. And if we had found the acceleration, right, we would see that the velocity sign is plus, but on the left side of 6, it's negative. So then we would be decelerating, or slowing down as we're approaching 6, because the acceleration would be an opposite sign. Now, when we do 7, I plug 7 in, I get a positive times a negative is a negative. Now, if we were to do the acceleration function at 7, we would see that it's negative, and it matches the sign of negative velocity. So the velocity and the acceleration match. That means it's speeding up. But again, think about it. It slows down at its peak, and then once it reaches its peak, it's falling back to Earth again, so it's speeding up again. So we know that we go from plus to minus, so we kind of have this situation here. So that is my highest peak right here. So I know it's at t equals 6 seconds. Okay. And that would be it for this one. Okay. So please let me know if you guys have any questions. That's all I'm going to really spend on this. I'll probably give you some velocity problems and stuff in your homework. But for the most part, that's going to do it for this section. I already have the next video for related rates made as well. So I'm going to post both of those today. All right, you guys, thanks for watching.